Hello, hello everybody. So I on behalf of Define welcome you all to today's session on advanced phishing threat, the real dangers of surfing web. Before I start touching upon the topics we are going to cover, it's important that I tell you about the speaker for today. I welcome Mr. Payton Miller, who is a bright cybersecurity engineer at Open Security team. He is a recent graduate from ACS Program at SANS Institute of Technology with several certifications under his belt, GSEC, GPEN, to name a few. He has quickly made a name of himself as a highly motivated self-starter, having a sharpened skill set and garden of reputation through participation in various capture the flag competitions. Payton brings a fresh take on a typical offensive methodologies. With a background in a web application development, he provides a unique outlook on exploiting misconceptions surrounding modern technology. Thank you for joining us today, Peyton. Over to Yashika.
Hi, I hope I'm audible.
Yes, yes.
So, before calling the speaker on, I'd like to give a brief outline of today's webinar and introduce a few concepts just to set the stage right for Payton to take over. So, phishing campaigns are commonly regarded as disposable, lightweight engagements that are easily deployed in the mass. But this assumption leads many individuals and organizations to ignore the persistent threat and the widespread dangers resulting from successful exploitation. Thus, it's important to note that while these operations can be lightweight, they can also be extremely thorough. In order to defend yourself, it's essential to understand critical ways that adversaries can leverage misconceptions to legitimize themselves further. So, today we will be discussing recent technological trends that make the web more accessible and easier to use, but at the cost of making the web as vulnerable as ever. These topics will range greatly from authorization through third party entities to how website sprawl can lower your security, the benefits of a good domain as opposed to hundreds of domains, and even current attacks that work and why they really should not. By understanding why phishing is such a persistent threat, you will be able to halt attackers in their tracks. But first, we need to understand their steps to gaining legitimacy. Only then we can begin discussing methods that you can employ to protect yourself from these vectors. So without any further ado, I request the speaker to take this session forward. Payton.
All right. Thank you for the wonderful introduction there. So my name is Payton Miller, as stated, and I'm here to speak to you about advanced phishing threats, the real dangers of surfing the web. Now, I'm a cybersecurity engineer with Open Security, and what I do for my day job is a lot of offensive technologies. And so what I do is web vulnerability assessments, penetration tests, anything offensive. And what I really love doing, more than anything else, is trying to find out how can I break things? And when I want to break things, it's not just one web application. It's not just two web applications. What I want to break is everything. I want to find a way to break the entire internet simultaneously. And that's not an easy task. But if I can find a way to do it, I'm sure as heck going to try. So before we go any further into this, I do want to give a very baseline what phishing is, why it works, how does it work, just to make sure that everybody here is on the same level. And so as we start out, what is phishing? And so in the terms of this presentation, phishing will be one of three forms to achieve social manipulation. What we're trying to do is get somebody to give us some type of information. Now, whether that information is whether or not file extensions are shown within an organization, whether or not it's how their internal structure works, what we're trying to find is some type of knowledge that we previously don't have. And with that knowledge, we can develop an attack against them. So techniques to do this are phishing, where we send an email or some type of message that poses as, hey, you need to click on this and interact with this, and you need to give us information. We can also call them on the phone and have a phone call, Hey, so I just sent you this file. Do you see index.html on your desktop? Now, if they do see index.html, file extensions are now enabled, and we know this. However, if they say no, but I see the index file that I just downloaded, maybe file extensions are now disabled, and maybe we can use that. This type of concept is incredibly simple, but with the more knowledge that we have, and it's incredibly easy to acquire, a simple phone call is all it takes. We can use this to develop an extremely verbose attack. And finally, smishing, where we send out arbitrary links through text message and try to gain legitimacy that way. In general, there's two historic trends of phishing, or two historic identifiers of phishing. We have the bait. You need to do something by this date, otherwise something bad will happen. If you want this money, you're going to click this email. Maybe you get an economic impact payment. You know, Corona times is happening. Maybe the government's sending you money. So if you click on my email, you can get money. But we also have to set a deadline. Unfortunately, the reality is new websites stem up all the time. And these phishing campaigns that we deploy, they only exist for 2 to 12 hours, typically, if we send them to a lot of people. So what we want to do is maximize the amount of people that will interact and click on this link and give us information. But we also want to make sure that we work fast enough that if we get reported and it gets taken down, it wasn't a waste. We've collected something. So we add deadlines to it. If you don't submit this data by Tuesday, your account's going to be terminated. If you don't transition to the new logon service, then we're going to have to lock you out of your account. And that's really unfortunate. And our IT team's on vacation. So it might take you a month to get back in. Just these simple linguistic tricks are oftentimes enough to put people on edge to where they'll do things that they typically wouldn't. So a few statistics before we get any farther. On average, a new domain registration is used for phishing between 2 and 14 days. Microsoft is used as impersonation 43% of the time. Now, Microsoft's a great target because everybody knows them. Everybody uses their operating system. Everybody's at least heard of them. And so if we pretend to be Microsoft, and even that person isn't technically savvy, they'll think that we're legit because they trust Microsoft. And that's really important as we go forward through establishing and growing legitimacy. Also, I want to point something out. With phishing, the initial goal is always credential collection. But in the presence of this application, within this presentation, we're going to cover maybe collecting personal data might be useful if we want to sell it. Maybe collecting medical information. So there's more than just collecting credentials, and that's really important. Because all of these things are profitable by individuals that sell this type of information. Why does this work? Because obviously the simple answer is don't click on links, don't submit your credentials. It's just that easy. Well, unfortunately, it just does. If I sent you this and you utilize Snapchat, your impulsive behavior would likely be to tap on this because it says tap to view. Also, anybody that's used Snapchat can tell you that if you tap on that, it will actually show you an image and it will load. And as an example, I do have 2 videos here. If you don't use Snapchat, so you kind of understand, if you tap on the left one, well, okay, now it's saved in chat. But if you tap on the right one, that's my Twitter. And so you kind of see there is no reason anybody should tap on this emoji and text that I sent on the left here. There's no reason, except for the fact that 100% of the people that I sent it to actually ended up clicking on that. Now, this is just a simple proof of concept of what we can do with understanding how applications work. For Snapchat, for instance, users get points for clicking on images that are sent and maintaining streaks. And so we can utilize that against the application. Now we have a way to get people to click on messages 24/7. There's no vulnerability here. There's no action. But in theory, if I found a 0-day, and that 0-day required somebody to click on a message I sent and maybe open an external link, I now have a way that works 100% of the time with no issues, because this is exactly how this app works. And obviously, visually, you should be able to discern and see the difference. And maybe you can, because this isn't a phishing presentation. But in the real world, you'll probably just overlook this. So moving forward, where are we? Well, we have a few issues on the internet. Let's imagine that we are a bank or financial institution. So maybe the bank has an investing platform, and so they'll have yourbankinvesting.com. Maybe they also have an internal employee login. So now they have yourbankinternalemplyeelogin.com. And maybe they also have financial advice, yourbank.com. You start to see how each of these services that this entity offers has a different website name. And so if you go to their homepage, maybe they redirect to each one of these. So the issue is you go to the website and you start moving around their site, and they keep sending you to other sites. So is it acceptable to say that if my bank sends me to a website, I should trust it? And honestly, most of the time the answer is yes. The issue comes with users have no idea who actually owns those websites, but they trust the redirection process. So in a lot of times, especially modern times, domain names have a ton, companies have a ton of domain names. They also don't necessarily list their domains publicly. So there's no way for an individual to tell whether or not that's a legitimate website. And part of that goes back to we shouldn't have sitemap.xml and we shouldn't have robots.txt, because those files on a web server provide too much information and show pages that we don't want people seeing, which means we also don't want people to see what other services we own. We've also seen rise of consent-based phishing, and this has come up as we use Microsoft as a platform as a service, and we try to grow businesses out of it. Obviously, it's created just for that fact. It's created just to host your business within it. And to implement all of these coding, all of these APIs, and to give power to the user, we're delegating permissions so that people can write their own code to extend what Microsoft has written. And so as you can see here, we have a application and it's requesting permissions. In very small text near the top, it says it's a risky application, it's unverified, and it would like to do a few things on our behalf. It would like to maintain access to data that we've given it. Okay, that doesn't sound so bad. It would like to read my contacts. I don't know how I feel about that, but still not that bad. It would like to sign in and read my profile. Okay, now that's kind of normal. It'd like to send mail as me. Okay, this is too far. It would also like to read all OneNote notebooks that I have access to, read and write to my mailbox settings, and have full access to every file that has been shared with me. And after we consider all of these permissions, we got to go back up to the top one. It wants to maintain access to all of this data. And how do we give it these permissions? Well, we click accept. That's it. It's just that easy. And now this application has full control to do whatever it like to our account. It can send mail, it can create new mailbox settings, and it can manage this data for an indefinite amount of time. Something else that we've seen is third-party APIs. And as we try to pursue security on the internet, this makes sense. I, as a business owner, do not want to store your email and password. I don't want to handle that information. I also don't want to store your credit card number, your social security, or anything else. The more data that I have to store in my database, the more liable I am if I get hacked. So how do we handle this? Well, we use something like Google or Facebook. And we say, okay, if you want to log in, I'm just going to open a page to Google. You can sign in and then redirect back to my site. And usually that works. But the issue is, if you as a user don't trust my website to save my email and password, then you shouldn't trust it to redirect to Google to log you in either, because that could be an issue. So real quickly, we'll talk about some legacy techniques that still work. The earliest I could find these written about was 2002. So say we want to purchase a domain name like Google. We can remove some characters, we can duplicate some characters, we can try google.net, google.org. And just real quickly, you can see a Python script I've written here, and it lets you come up with mistypings of Google. Now, is this really useful? Probably not. But as you get to the bottom and you start seeing googlenetwork.com, googledeveloper.com, maybe googledeveloper.app does sound legitimate enough that it could actually work. We also have something that historically has been a huge problem, and that is internationalized domain names. Typically, Unicode is not allowed on the web. Well, unless you're from that locale. For instance, as you can see here, Microsoft.com might look a little bit funky. And you can see the website address to the right, the puny code equivalent. It's actually xn-Microsoft-QY7C. That's encoding a Cyrillic letter where the rest of the domain name is Latin-based. And below it, we have another one, which is Twitter. Well, presumably. Twitter.com is entirely Cyrillic, but you can't use these characters typically with a .com domain name. So it is interesting but important to note that these types of things do exist. So what we have here is different characters from different character sets that are being used to create these domain names. And so they look a lot like the English variant, but they're actually using Russian characters or other languages. And so unfortunately, when you go to this website, it gets converted to xn-c1. We can't use this, at least not to host a website. We can send mail from this address, or I could send mail from this address for a very brief time. Now, you're probably wondering why I feel comfortable speaking about twitter.com or microsoft.com. And the simple fact is, honestly, Google will never give these back to me. I've been blacklisted. They've taken them from me. So I received this really nice notice from Google. Hi there. We've received reports for one or more domains on your account for phishing activities. That doesn't sound like me. Okay, it sounds like me. And Google will be suspending those accounts or those domains in 3 days. Please immediately take any necessary corrective actions to remove any malicious or compromised activity on the domains. You should conduct a review of the content and infrastructure, including website's content, application, and DNS servers, hosting, and security setup. Failure to take the necessary corrective actions and provide a response to this message, outlining steps taken the next 3 days, may result in cancellation of your domain registrations or termination of your account. Now, what's interesting here is that at the base level, we have two major things in this. First off, my domains, my website names, or my account will be suspended in 3 days. And if we think about phishing, that's a deadline. And the negative action is, well, this may result in cancellation of your domain registrations or termination of your account. So obviously I respond to this because I don't want them to take my stuff. And any company would too. Their automated response was, okay, please provide us scans, vulnerability assessment, that you've remediated these issues. Please give us a vulnerability assessment in the next 3 days. And so at this point, I was still talking to a automatic chatbot, and I didn't really know who I was talking to. But it's kind of interesting that Google thinks, okay, you've done something wrong. We're going to take your stuff from you. And the only way for us not to take stuff from you is for you to give us internal information about your environment. And if I was an attacker, This is the perfect ruse to put a lot of companies on edge because it's the perfect guise to push people far enough to give me internal information about their environment, and it scares them to take action. This is the perfect fish. Unfortunately, this is 100% legitimate and not a fish, and I no longer have Microsoft or Twitter.com. So next, we're going to discuss achieving legitimacy through complexity. And so for this, there's two simple attacks which we can pivot from a trusted website to our own website. And the most basic is open redirections. A lot of the time, login forms, after you submit credentials, they'll redirect you to whatever page you were trying to go to before you passed your authentication information. And what this means is if we find that page, we can type in attacker.co in that URL parameter. And after people submit their credentials to the trusted site, they'll be sent to our site, which is attacker.co. The other thing we can do is cross-site scripting. And what this allows us to do is run arbitrary code, potentially get cookies if the website's incredibly insecure. Otherwise, we could just redirect them to our login page and ask them to log in. And because this is so normal that you'll be on a website and you'll be authenticated and you trust it, and now it redirects you to a login form, you'll just think that your session became invalidated, and you'll happily type in those credentials. Another technique that we can use to actually gain legitimacy, as counterproductive as it is we can use link filtering. So what happens here is you type in a link and you send it to somebody through your email. And this link should be, like, for instance, google.com. And so what Microsoft decides to do is, as Microsoft, I'm going to place myself in between anybody that clicks your link and wherever that link goes. And then I'm going to use AI to try to detect maliciousness. And if I can detect that, then I can stop people from getting hacked. Now, the issue with this is, look at that link. Can anybody here actually sit here and parse what it says within the 3 seconds that you have to actually understand whether or not it's a fish? And honestly, no. Because you look at it and you can kind of see it's going to HTTP something something google.com, but maybe there's more to it than that. You really don't know where you're being sent. And that starts to be an issue because the security protection, which is supposed to protect you, it doesn't work, and it just makes people confused. So now we have abusable services. So if we found a way, in theory, to utilize these services, they're already online, everybody's already used them. So let's just use what we already know and utilize them. For example, t.co, the link shortener, that's Twitter. A lot of people here has clicked on a Twitter link. And so if we can have Twitter redirect to something malicious, maybe you'll trust it because it originated from Twitter. Facebook.me, here's a text message that got sent to a good friend of mine. Now, do we necessarily know that it's legitimate? No, and I've never seen fb.me, but I'm presuming it's owned by Facebook. Can somebody with a Facebook account create a link on there? Maybe. I genuinely don't know. And that's why this is scary. Bit.ly, everybody's used it. It's great for masking where you're being sent, and their response time's pretty slow. People trust Google, people trust Amazon. So host your files in Google Storage or S3 buckets. Additionally, if you want a free subdomain and you know how to host your own web files, you can use Firebase. And doing so will get you a .web.app subdomain. Now, these subdomains have to be hyphen delineated, and you can't use any other special character. But I would argue that Mozilla-Firefox-updates.web.app carries a lot of legitimacy if you can send somebody that. And they probably won't notice that it's a .web.app the first time you do so. Azure sites, I believe it's paid for now because they were having a lot of trouble with abuse. But what's interesting is, why would we go this hard? Why would we try to disguise ourselves this much? If we utilize a service that everybody's heard of through commercials or marketing, like WordPress, Wix sites, Squarespace, then maybe just having .wixsites.com is enough legitimacy that we can use that to attack people. Maybe .wordpress.com. People have heard of these services before, and so they'll inherently trust them. And finally, we have forms. As we mentioned at the beginning of this talk, phishing and credential collection is only one type. We also have sensitive data collection. And for that, we can use Google Forms, Microsoft Forms. These form platforms exist to collect people's private information. So is using them exactly how they're designed to be used technically nefarious? Probably not. And you do want to be careful because Google obviously does not allow credential collection. But if you're trying to get somebody's address, maybe Google Forms allows you to collect addresses. Maybe they're private information. It really depends. So we can also use trusted services. And for example, in this case, what if I was an adversary and I decide to send you an email? Now, this email actually has a meeting link on it, and so it's going to pop up for you and try to drop you into a call. And so in doing that, it's going to allow you to download my meeting software. Now, using this great power of open source intelligence, we can do some research and figure out who you work with. And if we can figure that out, then we can figure out and we can call a meeting with people that you work with on a daily basis. And by calling this meeting, it's everybody you typically work with. You didn't know there was a meeting today, but you're going to want to get into it. Because if not, your boss is going to be like, hey, you had a meeting today. Why weren't you there? You were needed. And so you're going to do everything in your power to get into that meeting in the next 10 minutes. Okay. So how can we use this? How can we abuse this? Well, if that meeting software is actually a Trojan, will you download it? And these are the types of questions that we need to start asking. Two case studies that are pretty cool. Recently, Fin7 has created a fake business that doesn't actually exist, and they've hired cybersecurity engineers to do penetration testing, red teaming. The issue is their business didn't actually exist, and all of the documents that they were giving to their engineers were actually forged. No company signed off on them. And so they were using legitimate engineers to deploy ransomware. Huh. This other example is maybe it's legitimate, maybe it's not. A company began paying individuals for payroll data. Now that kind of makes sense. Payroll data is first off, extremely sensitive. And if you have accurate data, you can make a lot of money from it. The issue is this financial startup began offering people $500 to anyone willing to hand over a username and password to collect the financial data. Now, I'm not saying whether or not this company is legitimate because I genuinely don't know. But the fact that they're paying $500 plus a monthly rate to collect your authentication credentials is pretty suspicious in itself. And I mean, honestly, that's definitely breaking your company's policies. As we start pivoting to more advanced techniques, this is more things we have to consider on the web. So OAuth is inherently trusted. Everybody has it, everybody wants to use it, everybody has used it. So from that example earlier, would we trust a website to store our email and our password? Well, maybe, but most times, no. If I can prevent it, I will not type an email and password into a website. But do we trust that website to then open an OAuth link back to Google? And a lot of the times it's a yes. And if you visualize that Google button as that Snapchat red button from one of the first slides, you'll start to understand that people just implicitly trust it. So I'm going to take a break from slides and show off something that I've worked on. So this is obviously not Google, even though it looks a lot like Google. And you can see there's been a new sign-in on it, Dell XPS, based out of Moscow, Russia. Interesting. Now, at this point, in the top right, it shows that I'm not logged in. And that's important, because if I'm not logged in, I shouldn't be able to see this sensitive data. But sometimes websites do weird things. Maybe this is information disclosure that I shouldn't have access to anyway. So, as we can see, we have two options. No, it wasn't me, or yes, it was me. Either way, it's going to ask me to authenticate. And so if I click one of these options, it'll bring up a box. And this box says sign in, click to continue to accounts.google.com. Makes sense. The issue is, this isn't actually OAuth. In fact, if I click this Firefox JavaScript thing, now it's a Firefox dialog. That's kind of interesting. And obviously Macs couldn't be targeted with this because that's not how Macs work. So let's click the Mac button and see what happens. Oh, not great. So as you can see, I can create these fake pop-ups using simple CSS, simple HTML, and simple web design. And a lot of people would inherently trust it because it makes sense. Oh no, somebody logged into your account from Russia. That's super bad. So what you need to do is go to this website and validate whether or not it was you. And when you validate, it'll bring up a form like this. And just as an example, I'll sign in. And we're going to load a little bit, make it look like we're actually trying to log in. Type in a super secure password, click next. It's going to take a moment to load, and look at that. Now I'm logged into Google. Except I was never not logged into Google. I just wasn't logged into this fake page. That's really important. So as we take a step back, what I've done here is created a three-dimensional window, which looks a lot like a new browser, which is exactly how we expect OAuth to work. And sure, the fact that it's showing me data, but also telling me I'm not logged in, that's kind of suspicious. But like I said, the web does weird things sometimes. This is normal. So it takes very little to no effort at all to create a page like this. And I can have it set up so it will detect whether or not you're using Chrome, Firefox, Safari, and it will adjust. Because every time you connect to my server, it passes a user agent with it. And using this type of knowledge, I can start to create very advanced attacks with very little effort. So now we're going to move into subdomain impersonation. And this is interesting for another reason. For some reason, you can have a subdomain that has 127 subdivisions. Why? That's a good question. Each subdivision has to be shorter than 63 characters, and in total, it cannot exceed 253 to 255 characters. Interesting. So for some reason, this happens to be valid. App.app.app. Now, is this realistic? No, and there's not much legitimacy to be gained here. But this is also 100% valid. Still really weird, and I would hope I would never see this, but it could happen. But what's really interesting is when you start combining this with things you expect to see, like http.steam.com.forum some numbers .homepage .whatever your domain is .com. And so now you have a valid subdomain, which kind of looks like Steam. And if the numbers are long enough, all you'll see is the beginning of that. This is starting to seem a little bit powerful. As you can see here, all of these things are 100% valid, and I loaded them into my registrar. Happy as can be. I've since removed them because I don't want to be banned again. Google. And so all we have to do is find a really long URL that we want to gain trust with, use a little tool that I wrote, and it is available in the repository that's listed at the end, and then update your DNS to reflect that. And so all you do is fill out this form. It runs the 3 or 4 regex commands on the right there, which enumerates those steps. It replaces equal signs with hyphens, and it replaces any tall standing character that you would expect in a URL with hyphens. Then it deletes bad characters that shouldn't be there. And a lot of the time, that's all you need. For example, I have cdn.discordapp.com -attachments-numbers-numbers. Now, what would you initially think the domain name? And this is a rhetorical question as I can't hear you or see chat currently. But in all reality, it's test.download. Even though you see the cdn.discord.app or discordapp.com, it's whatever the last 2 elements are in the domain. At least that's typically how it is. There are ways to bypass just about everything. You just have to look hard enough. So something that I've done a lot of research into in the past year, and it's really interesting because 3 days after giving this presentation, more research came out about it, and it's actually the invisible Trojan source code attack. I did not discover or assist them in researching that, but it does fall in line with what I'm about to show you. And so we can use Unicode characters like left to right overrides and right to left overrides. Now, what these characters do is they will switch the text encoding from going either from the left to right to left, or vice versa. So as everyone here should know, some languages like Arabic start at the right side of the screen, work their way to the left, while English is left to right. So if we can jump between these 2 forms simultaneously using something called bidirectional text encoding, we might be able to not necessarily fool the computer, but fool the computer's users. As you can see here, on the left, I have some displayed file names. And this is what it will look like when you open these files in Windows. The Unicode file name in the middle, that's what I have to type out. And as you can see, the Unicode file name in the middle, the last 2 to 3 characters, that's the true file extension. And this might be a little bit hard to see, but if we take the first one, for example, it looks like 2021 xcod dot written out in its Unicode form. And using the Unicode visualization, we can see that it ends with .exe. However, if you look at the displayed file name, the only place that there's a .exe is that first word, .executive. So we've just moved the file extension from the end of the file to the middle. But surely, we can't do anything with this, right? Well, in the second case, we do something a little bit messy. We use a .link file to act like it's advertising for B-Sides Inc. And maybe it's marketing information. On the third one, we disguise the file extension by a fictitious company that doesn't exist, J. Schaefer. Ironically, it's .js, but it looks like J. Schaefer. And anybody that sees that period at the beginning is probably going to dismiss it. And the last one's very interesting because it's Amazon.com. And the issue is .com, when you run a .com file on Windows, it runs it as a .exe, which means this is now Amazon.com which is technically an exe, but it looks like Amazon.com invoice.pdf. Interesting. And here's a different visualization. In the table, I've bolded the various file extensions, so it's kind of easier to see, but it's really not. And that's the issue here. To the computer sees the Unicode form. To the average user, the user sees the displayed file name. Huh. So as you can see here, if you have file name extensions disabled, you have a harder time of hiding this, especially things like executive summary. But if you know that file name extensions are enabled, then you can do some of these more advanced payloads. The issue being, if you do have it disabled, the only thing that's going to change is now J Schaefer is now Schaefer. Amazon.com is now Amazon invoice. So even disabling or enabling, a lot of these, it doesn't even matter. Executive summary is the one exception, and that's because the file extension is actually in the word itself. But we can also see with the file name extensions enabled, that's kind of cool. And now I'm going to show I also have a generator that I've created. It's available on GitHub. And it lets you play with these things. Effectively, what I tried to do was I wanted it to be able to generate using RTLL and LTRO characters without having to inject the symbols myself. That seemed like a lot of work. So as you can see here, what I've done is WWHF webcast, and then I put a lot of noise.wmv. And you can see down the bottom, that's a WSL console. And it has all of that noise that I implemented, except the actual file extensions.exe. Kind of interesting. And you can also see the Unicode character that it put in as the square with the question mark on it. These are two other applications of this type of vulnerability in two other commercial applications. Now it's kind of interesting because on the right here, we have a zip file preview, and it has the Amazon.com invoice.docs, and it looks like it's a .docs file. Now, anybody here listening should be able to tell you that's actually an executable, and if you download and run it, it's likely malware. And on the left here, we've done something interesting. I'll give you a moment to try to figure it out, just real quickly. So on the left here, what's actually going on? And a lot of people here will kind of jump to the conclusion, oh, it's mail spoof. Because obviously you don't have a Microsoft.com domain or email on Microsoft.com. And that's a fair assumption because I don't. In fact, it's something much worse because this is not spoofed. I actually haven't spoofed the from header. But what I've done, and you can see, currently my email is cc.pp1, or sorry, I mistyped. But you can see my email. The issue is when you implement a character override, you can do things like this. And so now instead of becoming Microsoft.com, you can see my true domain name, which is lit.cc. So that's kind of interesting. I have managed to spoof a Microsoft.com domain by typing in my username backwards. How's that work? That should be some violation of the web. And unfortunately, this type of thing exists in applications all over the place. So what can we do? The whole purpose of this presentation was to try to give some type of inspiration of how we need to change the way we think about this. If we think about phishing as a bottom tier, as just a haphazardly sent message that just says, download this. If that's what we dismiss it as, we're missing the biggest thing. The majority of ransoms they start by this type of vulnerability. And if you implement any level of creativity here, well, everybody's going to fall for it. And it doesn't take much effort at all. But the issue is we assume that fishes are bottom tier. They're bottom shelf. They're copy, paste, send. And there's no solution to them. And unfortunately, if we don't teach people how to understand what the internet actually is, and we don't teach individuals how to use the internet, it won't get better. Teaching people not to click on links isn't sufficient. So what can we do? And that's where it starts to get hard. In the case of layered and transparency attacks with OAuth, well, we could use a password manager. And so if that password manager doesn't detect a new URL that opens to Microsoft or Google or Facebook, then it's not going to fill in your username and password. And maybe you will then open up your password manager, say, oh, this thing's broke, it's not working. And then copy your email and your password into that form itself. But what you've just done is thought about it for probably 30 to 45 seconds while you open that password vault and you copy your information out. That hesitancy may be enough to keep you from submitting your credentials. Two-factor authentication. Now, the downside of this is if you send me your username and your password, then you're probably going to send me your two-factor authentication too. The catch is I now have all the information. And if it's a email-based 2FA, I have 15 minutes to use it. If it's text messenger based, I might have 5 minutes to use it. And as an attacker, that might become very expensive. The other downside is I may have to be geographically close to you, and there might be some validation on the server. So I might actually have to have a server within 50 miles of it to be able to use that 2FA. We did mention very briefly that domain names are typically used within 2 days to 2 weeks. So I hate this recommendation because safe site scanners in 2021 is not a great defense mechanism, but if they do detect brand new websites that just spun up, that might be enough to keep you from getting phished. Another completely off the rails suggestion, use a custom Chrome theme. If I send you a site like this, I have to assume that you're using the default Chrome. And I have no way to determine if you're using a rainbow theme or not, or a bright red one. And so that window that I pop up, it's always going to be default Chrome or dark default Chrome. So maybe a theme is just what you need to protect yourself. The historical recommendation, if clicking a link is avoidable, navigate directly to the website instead. If you get a message, an email that says, hey, this is your bank, you need to reset your password. Well, go to your bank's website and then manually reset your password yourself. And I would say this works for, your Bitcoin wallet, your Coinbase. Maybe it works for important emails or important bank accounts. But in everyday life, it's not a realistic suggestion. If I expect you to search and try to find these websites on your own and not use your email the way that email is designed to be used, your productivity as an employee is going to fall so far through the ground that you'll likely be let go. So it's not a realistic expectation, even though that's what everybody wants. And from a security perspective, it's a perfect solution. Just don't click on things. But also, you do have a day job, you do have expectations, and you do have access to confidential information. So the biggest thing, regular internal training can kind of ease and show these types of threats to individuals. And that's what I tried to do here today. So how to protect your organization? The biggest way is DNS, SPF, DMARC, and DKIM records. What these permit you to do is deny anybody from spoofing your email. And on top of that, if you are a business owner, try to reduce unnecessary domain redirections. If you have your homepage redirecting to every other service under the sun, then people are just going to trust wherever your site sends them, which may or may not be great considering what your business is. For Google, we kind of assume that Google has to send us to other pages because it's a search engine. That's why it exists. But for a bank, no. A bank shouldn't be redirecting you 16 times to a bunch of different domains. And if they do, maybe they need to give us a list of what they actually own so that we can be safe. And finally, the biggest suggestion is to maintain web servers with regular vulnerability assessments and ensure that your services are actually secure. Now, real quick, I'm going to talk through effective training techniques and ways that we need to try to train people to dismiss phishing threats. And so, in an ideal world, companies should pursue an open relationship. They should offer benefits to individuals that want to learn. For example, hey, you didn't fall for a phishing campaign. You're now entered into a $250 gift card lottery. Congratulations, because you reported that phish. And if we have this type of engagement between our security team and everyone else, suddenly the security team isn't the villain. And it actually seems like the security team wants to help people grow. The issue with this is executives love statistics. And how do we get valid statistics? Well, we have to do the same test time and time again. But in the real world, that's not how this works. If I give you a fish pretending to be Netflix every quarter for 5 years, nobody's going to trust messages from Netflix in your organization. That's how that works. But if we can do creative and different solutions and see what works against your organization and what doesn't work, I feel like that's a lot more valuable to everybody and for everybody's time. As previously stated, training individuals not to click on links will likely result in loss of productivity. And our reports that we have to give out, something that's really interesting, is how many people actually viewed an email. And this is something that I've seen people punished on because, oh, well, it was obviously a phish. You shouldn't have clicked on that email just to load it in your browser. And that's super not great either because how can you tell if it's a phish from the subject and the first line? And the only way this would result in anything bad happening would be if there was a 0 day. And that's incredibly unlikely and incredibly expensive. So what that statistic should be is, well, X amount of people from your organization actually received that message. Not X amount of people should be punished because they clicked on a message. Otherwise, again, people will stop using their email and their productivity will fall. The final thing, my final note here, we're not adversaries. But the adversaries, they don't really have morals. They don't want companies to be happy. They don't want the company's workers to be happy. They will do whatever they want to get their way. And this includes offering bonuses, offering promotions, acting like they're going to give you a holiday check because they can get away with this type of stuff. If we do it as an emulation, as a realistic emulation, we won't get your business ever again. So at the end of the day, simulations are simply simulations. I have a few additional resources at the end of the presentation, some blogs and other content that I've read through in preparation, a few tools to actually perform social engineering. I figured I'd let you guys explore and try your hand on your own time, just because I feel like these types of concepts are more important than learning any single tool. With that, I'll open the floor to questions. My Twitter and Discord are there if you'd like to reach out. And for the time being, I'll hand it over to Yashika.
Thank you so much, Payton. The session was really engaging, and personally, I have all my questions answered, but we'll open the floor for questions if the audience has any. We'll enable the mic option.